Hey, what's up, guys? This is Cheng here. So LeetCode number 1996, the number of weak characters in the game. Okay, so you're playing a game that contains multiple characters, right? And each character has two property, attack and defense. Okay, then you have a properties array to represent those two properties, right? And then your a character is said to be weak if uh, if any other character has both attack and defense levels strictly greater than this current character, then we can say this character is weak, right? Basically, it's weaker than some other characters, right? And then we need to return the number of weak characters, okay? Right, so example 1 here, this one is 0 because there's no character is whose both attack and defense is strictly smaller than other characters, and for this one is 1, right? Because the first character is smaller, it's weaker than the second character, right? And then for this one, it's the same, right? So we have this one, but for this one is smaller. This one is weaker because this one is not. See, the defense it's greater than all of the others. And then some standard constraints, right? So this problem, uh, at at a first glance, this one seems pretty straightforward, right? We just need to somehow compare that, right? Compare each character, but since we have this kind of 10 to the power of 5 constraints, so so apparently the brute force way will TLE, which is for each of the character, right? We compare with all the other characters, right? And if any of the other characters is greater than both the attack and defense, then this character is the is the weak characters, right? And then so how do we improve that, right? So the tricky part for this problem is the sorting. Okay, for some reason, not for some reason, somehow we have to sort it in a way that um, we can process them correctly, right? So let's take a look at an example. Let's say we have 1 1, 1 2, 1 3, and then 1 7 and 1 6, right? And then we have this kind of maybe 2 4 and then 2 5. Okay, so for example, we have this characters. So what are the weak ones, right? We only have 3, which is this 3, right? I mean, apparently, uh, all the characters who have the same either attack, who have the same attack, they will not be weak ones, right? So because both of the attack and defense, they have to be strictly smaller, right? So the tricky part is that how can we compare between groups, right? So as you guys can see, we have basically here we have two groups. The first group is the whoever starting with 1, and second group whoever starting with 2. Okay, and let's do 3 here. Okay, so the reason that we have these 3 weak characters is because this 3 is smaller. 1, 2, 3 is smaller than 5, right? 5 is the greatest defense, right? From the previous group. Okay, so what we can do is that first we can sort by the first character in descending order, right? Basically, it's x0. In that case, um, we can make sure the first property, which is attack, is either equal or smaller than the previous one, right? And then the next question is that how can we check the defense in this case, right? So first, so what we can do is that we can maintain like a current max defense that we have seen so far. Right? At the beginning it's 0, right? And then whenever the current defense is smaller than the current, whenever the defense is smaller than the current max, right? Then we know we can do an answer plus 1 here. And and in order to accomplish this one, for the second sorting here, we sort it in the ascending order, which is 1. So this one is making sure for the same attacks, right? We start from the smallest defense value, so that this condition will not be true for the same attacks, because since we are like sorting it in the ascending order. Excuse me. Right. So for example, right, if we have like 2 and 3, right? So at the beginning, current max is 0, right? And then so here we have 2, 3, and then the max will become current max will become to 3, right? And then we start processing this 2, 5, right? So now d is equal to 5, and 5 is greater than current max, right? So basically, so what we are accomplishing here is that within the same group, this condition will never be true, right? Because we're sorting this one in an ascending order, but across between the groups, this one might be true, right? Same thing, right? So let's say we finish processing this group 2 here. Now we move to group 1. Okay. So whenever we move to group 1, we do the same thing, right? We also want to start from the smallest, because like we do the sorting here, right? So we start from 1, right, and 2 and 3, because so whenever this one is true, okay, then we're sure, okay, we're looking at a weak number, right? A weaker like a weak character for sure, because now the in order for this one to be true, first, we have to move to another group, which which has a smaller attack, right? Again, because within the same group, this one will never be true, right? So whenever this one is true, right, we're sure that okay, so we're in a strictly smaller attack group now, okay, and then when this d is smaller than current max, it means that okay, uh, because because the first one we are processing is the smallest from this group, right? And then if this one is smaller than the current max, at this moment the current max is the biggest one from the previous group, right? And if this one is true, then we know, okay, so this one is strictly smaller than the previous than some number from the previous group, right? And then keep doing until we have reached this one, until we have reached 1, 6, right? In this case, 6 is greater than 5, right? That's why this one apparently is not a weak one, right? But then after this one, we still need to update this max, do a max of this one plus the current d, right? This is because even though this one is not a weak one, but there could be another group, right? Let's say we have attack 0, right? So for this one, you know, the weakest one, the biggest one is 7, right? So let's say for example this one like 5, 6, 5, 6, right? So if we don't keep updating the current max from the current group, then we might, so for this kind of for the next group, for the next group has a smaller attack, we may not have the correct attack here, the defense value here, right? Which is 7 in this case. Yeah, I think that's it, right? I mean, so for this one, the coding is very straight, short. The tricky part is how can you figure out the sorting to make sure we can handle those either attack and defense correctly, right? Within the groups and between the groups. Okay. So properties dot sort, right? So we have a lambda functions here. So we have first we sort the attack in a descending order, right? X0. Second one is the ascending order, right? And then we have answer equals to max dot zero. Okay, for A, attack and defense in properties, right? So if defense is smaller than the current max, right? And then answer plus one, right? And then update max equals to max of max dot d, right? Return answer. I think that's it, right? So so that's it, right? I mean, time complexity apparently it's unlog, right? Because we have sorting at the very beginning. Um, yeah, so that's it. I mean, this one seems pretty straightforward, but you know, figuring out the sortings and the sequence to process each one of them and then to maintain this max, it's not that easy, to be honest. So, but anyway, so that's it for this one. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.